Understanding the revenue and cost structure that will lead to profitability is essential to success in business. This video will illustrate how to use linear equations to optimize revenue and cost structure, including break-even analysis. Let's start out with a new business example to illustrate my points. I might be able to get access to a large number of unsold electronic devices with 5x7-inch screens. I believe I can reconfigure these devices, but they will only work on Wi-Fi connections and play some basic games. I plan to call these my books, and I expect to sell them at $125 price point per unit. In addition, I believe I can acquire them for a low cost of $37.50 per unit. I also did some additional cost estimates where I believe that I can set up a facility to reconfigure these devices for about $225,000. I am planning to go on the internet show called The Goldfish Bowl to try and win the $225K. Now, let's work through each component of this business model one step at a time. First, we start with the revenue function. Here, the total revenue for the venture will be $125 times each unit sold X, as you can see here. Next, we will look at the total cost function. Here, each unit will cost $37.50 plus the $225,000 fixed cost or investment to launch this venture. Now, we can combine these two linear equations to create a profit function where we subtract the cost function from the revenue function, as you can see here. Take care to start out by putting the cost function in parentheses, or the result will be inaccurate. So our profit function is equal to $87.50 times X minus the $225,000 fixed cost. Note that the $87.50 is our profit margin per unit, often simply called margin. It is also called contribution margin. One way to think about this is that we will contribute $87.50 to cover our fixed cost and eventual profit for each unit that we sell. Let's look at some questions to test our knowledge. First, what is the profit or loss if we buy and sell 1,000 MacBooks? Here we plug in 1,000 for X, and we see that we result in a loss of $137,500. Second, what is the profit or loss if we buy and sell 5,000 MyBooks? By plugging 5,000 in for X, that results in a tidy profit of $212,500. Third, we want to know the minimum quantity of MyBooks that I need to sell in order to break even or at least have a slight profit. In this case, we set the profit equation equal to 0 and solve for the X unit quantity. I first add $225,000 to each side to isolate the term with the X variable. Then I simply divide each side by 87.5 to find the minimum quantity to break even. This leads to a break-even quantity of 2,571.4 units. We round this up to 2,572, which will give us a very small profit, as you can see here, as opposed to rounding down to 2,571, which would result in a slight loss. My final question here is, what is the total revenue at the break-even point? Here, we will go back to our revenue function and plug in 2,572 for X. As you can see, that will result in a total revenue of $321,500. Here is another look at the break-even formula that many of you may recognize. Here, VCU stands for variable cost per unit, which was $37.50. You simply take the total fixed costs and divide it by the price minus your VCU. Finally, we can make a nice plot combining the revenue, total cost, and profit functions. Notice that where the revenue and cost functions intersect is also the point at which the net profit line crosses from negative values or losses to positive values or profits.